Function g is defined by this. We've got some logs dividing each other. Told that x is greater than 0, x can't equal k. Deduce the value of k. So k is going to be when the function's not defined. It's going to be when the denominator is 0. So ln k minus 2 is going to equal 0, meaning ln k is 2, and k is then going to be e squared. We're just undoing the log. You might raise both sides of the power of e if you want to, and then cancel that out. Or just kind of think about it. It's when you have, say, log to base 10 of 100 equals 2, it's 10 to the power of 2 is equal to 100. So here we're doing e squared is equal to k. We're then asked to prove that the derivative is always greater than 0, so I'm going to need to calculate it. We are given the quotient rule in the formula book. Now it's in terms of f and g, but normally we use u and v. So just replace by u dash v, v u dash, and then v squared. So this is going to be my u at the top, which means u dash will be 3 over x. I just differentiate ln x, which is 1 over x, and times it by 3. And then v dash is just going to be 1 over x. So g dash x. Forget the f's and g's in the formula. I've changed them all to u's and v's. So I'll get f dash, which is my, u dash, which is my 3 over x, times v, which is ln x minus 2, minus 3 ln x minus 7 u times my v dash, which is 1 over x, all over v squared, which is ln x minus 2, all squared. Okay, time to expand this up, I think. So we're going to get 3 over x ln x minus 6 over x. You just times the 3 by the minus 2. Then minus 3 over x ln x. Then I'll get a plus 7 times 1 over x, so plus 7 over x, all over ln x minus 2 squared. These terms are just going to cancel out. I'll then be left with 1 over x, all over ln x minus 2 all squared. To tidy it up a little bit, we can times top and bottom by x, basically bring that x down. Okay, and then because x is greater than 0, this is always greater than 0. And because this is a square number, this is going to be greater than 0. And therefore the whole thing is going to be greater than 0. X greater than 0. And so, I don't know, I just feel like I need to clarify it a little bit. It can't equal 0 either, remember, because x can't is not allowed to equal k, the e squared. That is enough. Part C, we're then asked to find the range of values of a for which the function is greater than 0. Okay, so I'm going to construct an inequality now. So 3 ln x minus 7 over ln x minus 2 is greater than 0. Now, just be careful here. You can't just times through by ln x minus 2 because it could be negative, and that changes the whole dynamic with an inequality. So we're going to look at two different cases. Remember, x equals e squared, which is when the denominator is 0. So let's look first of all at when the denominator is greater than 0, which is going to be when x is greater than e squared. That's going to be case 1. And then I'm going to take a look at when ln x minus 2 is less than 0, which is when x is less than e squared. So if the denominator is greater than 0, I can just times through by it, which is going to give me 3 ln x minus 7 greater than 0. And that means ln x is going to be greater than 7 over 3. And I can undo this inequality. X is going to be greater than e to the 7 over 3. So it has to be both. It has to be greater than e squared and greater than e to the 7 over 3. But if it's greater than 7, e to the 7 over 3, it automatically is greater than e squared. So this is going to be one solution. What about if ln x minus 2 is less than 0, or x is less than e squared? This time, when I times through by ln x minus 2, which I can still do, because it's negative, the inequality sign swaps around. So we're left with 3 ln x minus 7 is actually less than 0. I've just realized this, it looks like I'm making a fraction. So this is case 1, and this here is case 2. Okay, so this time I'm going to get almost the same thing, but ln x is going to be less than 7 over 3, and therefore x is going to be less than e to the 7 over 3. So now I require x to be less than e squared and less than e to the 7 over 3. It must therefore be less than e squared. That one's going to win out overall, because if it's like e to the 2.1, it satisfies this, but not this. So it's got to be that as my overriding one. And that's my overriding one for the second one. So I just need to bring these together. I'm not asked to use set notation or anything, so I'm not going to worry about that. Therefore, overall, and we just need to remember x also is positive. Okay, kind of forgot about that. Should have probably included it here. So it's less than e squared, but it had to be greater than 0. So overall, I'm going to get that 0 is less than a, which is less than e squared, or a is greater than e to the 7 over 3. In fact, it's most values is just the values between e squared and e to the 7 over 3 where the function would become negative. Okay, good question. Just be really careful with the inequalities, and then it does work out all right.